Dear students, this is Dr. Viju Vasudevan. In this video, we will discuss chapter 12.1 Orthogonal Functions. Orthogonal functions. First, we will see the definition of inner product. Recall that U is a vector with three components U1, U2, and U3. V is another vector with three components V1, V2, and V3 in three-dimensional vectors. So remember the vector space, vector calculus that you studied in calculus 3. The inner product or dot product, you might have studied dot product. In other words, it's called inner product of two vectors U and V is a real number. When you find the dot product of two vectors, it's a real number, isn't it? It's called a scalar, defined as the sum of the products of their corresponding components. For example, U vector is I, J, K vector. V vector is 2I minus J plus 3K vector. How do you find U dot V? You remember it. 2 into 1, isn't it? I dot I will be 1. So 2 minus 1 plus 1 will be minus 1 plus 3. So the answer is, isn't it? 2 minus 1, 1 plus 3 is 4. So this is a scalar. This is what I explained here. U1, V1, first component versus first component, isn't it? Plus second component, second component, third component, third component. That is called K from 1, 2, 3, UK, VK. Right? This is called inner product in other words in case of algebra. The product UV possesses the following properties. It is commutative. U dot V is equal to V dot U. Scalar, when you multiply scalar with the first vector, it is equivalent to multiplying the scalar with the output of the dot product. Doesn't matter K comes here or here, right? And U dot U is 0 if and only if 0 is one of them is, if U is 0, then its dot product with itself is 0. And U dot U is greater than 0 if U is non-zero. For any non-zero vector, the norm is greater than 0. That's meaning U dot U will give you norm U square. You remember it? Check it. Because U dot U will be U1 square, U2 square, U3 square, and this is norm, isn't it? Norm square. Actually, you will find this one, which is norm square. Without square, it will be norm square. That will be the case. And U plus V comma W can be distributed like U comma W plus V comma W. These are some properties of the inner product spaces, which is in other words called dot product. Now, inner product of two functions. Instead of vectors, we get functions. Inner product of two functions f1 and f2 in the given interval, in the closed interval a b, is the number which is given by the integration. We are multiplying these two functions and integrate the output from lower limit to upper limit with respect to the variable x, which is called inner product. Actually, the notation will be looking like this one: inner product of f1 comma f2, isn't it? So instead of two vectors, we get two functions. The inner product has been defined as the integration of these two functions from the lower limit to the upper limit of the interval. Orthogonal functions. Now we see what is orthogonal function. That is the title of this chapter, isn't it? So in the above definition, if the inner product is 0, then these two functions f1 and f2 are called orthogonal to each other. We know in dot product, what is dot product? U dot V is norm U, norm V, cosine theta. If theta is 90 degree, cosine 90 is 0. So U dot V is 0, isn't it? If dot product is 0, we know that two vectors are orthogonal. So two functions are orthogonal if its inner product is 0. So if inner product of f1 comma f2, which is the integration of the product of these two functions from a to b, is 0, then we call these two functions orthogonal functions. This is what the major topic of this video. So So you will get two different functions f1 and f2. You are going to multiply and integrate them from the given interval, lower limit to upper limit, with respect to the given variable. If the answer is 0, you say they are orthogonal. The answer is non-zero, you say they are not orthogonal. Non-orthogonal, right? So orthogonal set. In this definition, we have seen only two functions are orthogonal. So now we take a set of functions, a series of functions. There are many. Sequence, there are many. The first one, second one, third one, 5, 3, up to infinitely larger set. How can you call the entire set is orthogonal? When you pick any two, we pick any pair of two functions, and the integration is 0. It's orthogonal inner product of the any pair of functions 0. Then we can say that the entire set is orthogonal set. Orthogonal, so that is very important. So you have assume that you have a set of n elements, phi 1, phi 2 up to phi n. Now you pick any two. You can pick phi 1, phi 2, or phi 1, phi 3, phi 1, phi 4, phi 3, phi 10. Any two vector functions you can pick. The inner product should be that is the integration of those two functions. The product of these two functions should be 0. If it is 0, then for any it is true for any two. That is why it's called m not equal to n, phi m, phi n, isn't it? Two different functions are chosen, or its inner product is 0, then the entire set is called orthogonal set. Okay, so we should generally check for any two function phi n, phi m. That is it. Here orthonormal set, slightly different from orthogonal. Here, if the norm of every function is the length of every function is given as 1, then the orthogonal set will become orthonormal. See, there are two properties to satisfy orthonormal, one property to satisfy orthogonal. In the collection of all functions, if they are pairwise orthogonal, the set is called orthogonal set. If you add one more property, that the norm of every function, inner product with itself, square, isn't it? So inner product of phi 1 with phi 1, which is its norm phi 1 square. If you find the norm 1, which is nothing but integral a to b, phi 1 with phi 1, you are integrating dx, and the answer is 1. The norm of this function is 1, then it is called the entire orthogonal set will be called orthonormal set. That's what I explained here in this PowerPoint. The norm. What is the norm? All this you know already in calculus 3. Might have studied the norm of function, finding the norm. Here norm is phi n of x, which is inner product of phi n with itself. So phi n into phi n square will be integrated from the lower limit a to upper limit b. And if the answer is 1, then it means that this is true for every phi n, isn't it? So phi 0, phi 1, phi 2. Then this orthogonal set will be called orthonormal set. So remember this property. That's it here. Now orthogonal set with respect to weight function. We have a set of real valued functions, phi 0, phi 1, phi 2, phi 3 is going on, isn't it? We want to say this set is orthogonal with respect to another function w of x. So they have to be pairwise orthogonal. When you multiply two functions and take the integration from from a to b with respect to weight function. So multiply weight function along with this product and then integrate. If still the answer is 0, we call this is orthogonal with respect to the weight function. Otherwise not. If it is non-zero, then it's not orthogonal, right? So in the previous chapter definition, it was just orthogonal set. Now this orthogonal set with respect to another function called a weight function. Most of the time weight function will be 1. unless otherwise specified. The previous case, if you take weight function w of x is 1, you will fall in this previous category here. Okay, that's it. Now we have to verify, prove that the given functions are orthogonal on the indicated interval. Here two functions are given, f1 and f2, interval is -2 to 2. What is the formula? The inner product of f1 and f2, we know what is the integration from a to b, multiply f1 and f2 and dx. So integration -2 to positive 2, f1 is x, f2 is x square dx. And you remember, when the limit is symmetric, from negative to positive the same number, and the function is odd, without integration we can say the answer is 0, and you can integrate it, isn't it? If this term is of even function, then you can write 0 to 2 times x power 4 dx, isn't it? It is possible to simplify. But when the function is odd function, integrating from negative a to positive a, the same number with the different signs, isn't it? The function f of x dx will be 0 if f of x is an odd function. What is odd function? An even function. Can you tell me? F of negative x is equal to negative f of x. If a function satisfies this property, it is called odd function. F of negative f is equal to f of x. This function, this property will give you even function. This property will give you odd function. So write in x cube, f of x. Take this g of x is x cube. Replace x by negative x. F of g of negative x, it will be negative x cube. So it is odd function. The degree is odd, obviously, isn't it? Okay. So this is simply verified. Now I'm going for the next problem, problem number 5, to verify. Problem number 5. Integration. So we have to find the inner product of f1 and f2, which is integration from a to b, product of the functions, and integrate with respect to dx. Write down what is limit negative pi by 2 to positive pi over 2. f1 of x is x, f2 of x is cosine 2x dx. Good. You can choose integration by parts. So take u is equal to x, so u prime is 1, u double prime is 0. dv is equal to cosine 2x dx. v, integration of cosine 2x will be negative sine 2x over 2. So we use this one, the formula integral u dv is equal to uv minus integral v du. u is x, v is negative sine 2x. So this is not negative, positive. Cosine will not give you negative. When you integrate, when you differentiate, it will be negative. It is positive over 2, and integration limits are negative pi by 2 to positive pi by 2 minus integral v du. What is v? Sine 2x over 2 du is dx. u is x, so du is dx. Now the first part will be x. X will be pi by 2 sine 2x. 2 pi by 2 will be sine pi is 0. So when you substitute upper limit, it will be 0 minus lower limit, still sine negative pi by 2 times 2. Negative pi will be again 0, whatever the x is. Now when you say this term 1 by 2 negative 1 by 2, I would say when you integrate sine, it will be negative cosine 2x over 2 from negative pi by 2 to positive pi by 2. Here the limit should have been written. Okay. come out. This will be negative and negative, positive outside, 1 by 4. Now cosine 2 times pi by 2, cosine pi is minus 1, minus cosine negative pi, even negative pi is also minus 1, because cosine is even function. Minus 1 plus 1 will be 0. The answer is 0. The answer is 0. Verified for problem. So they are orthogonal functions in the given interval. We don't know beyond this interval. In this given interval, these functions are orthogonal. Here another set. Now we have been given a set of functions. Set of functions. In this set, what is this set? Or you write this one. The set, call it S1. N is 1. It is sine x, sine 2x, sine 3x. It's going on infinitely larger. The set. The given interval A is 0, B is 1. Okay, now first we will we have to assume that m not equal to n. We choose two different functions randomly, isn't it? We can take inner product of sine nx sine mx. This n and m can be any two different numbers, maybe 2, 3 or 3, 4. If you generally take a n and m, we can generalize the concept, so it may be true for all values of m and n. So there is the formula is integration from lower limit 0 to upper limit pi sine nx and sine mx dx. Well, how to simplify this one? We should have a formula. I just write this one as equation number 1 and recall some formulas. Cosine A plus B, we have a formula, cosine A cosine B minus sine A sine B. Similarly, cosine A minus B will be cosine A cosine B minus plus sine A sine B. Call it equation number A, equation number B. When you sum A plus B, what do you get? No, when you subtract, you get a different answer. You will get 2 cosine A cosine B is equal to cosine A plus B, the left side, plus cosine A minus B. Now we don't want cosine A cosine B. We want another part. So we will do B minus A. B minus A. From this one subtract A. So this negative will be positive. You get in the right hand side 2 sine A sine B. In the left hand side you are subtracting B minus A, isn't it? So you will be getting cosine A minus B minus cosine A plus B, and we want this formula because we have sine A sine B. This is the formula. So this 2 will be divided on the right side. Okay, now we will go to a different page. We will solve it. What is it? Inner product of sine nx sine mx, which is from 0 to, in the interval 0 to pi sine nx sine mx dx, and we have found the formula that sine nx, otherwise we can write sine A sine B can be written as 1 over 2 cosine A minus B plus cosine A plus B, minus cosine A minus B minus cosine A plus B. this rule we use here. Therefore integration becomes 0 to pi. So instead of nx, instead of a you have nx, so a is nx, b is mx. Write this one. So 1 over 2 cosine a minus b, nx minus mx, minus cosine nx plus mx dx. So in the next step we will write 1 over 2 integral 0 to pi cosine, the constant is n minus m times x. Now this is a function, this is cosine, minus cosine n plus m times x dx. Now integration starts. When you integrate cosine, it will be negative, it will be sine, isn't it? So sine n minus m x over n minus m, here minus again sine n plus m x over n plus m, and now 0 to pi. Since all the terms are sine, both the pi and 0, when you write n and m are integers, remember in this given problem n and m are integers, they cannot be half or 3 over 2, isn't it? N and m are integers, so x can be replaced by pi, upper limit sine any number of pi, sine n pi is 0, so upper limit is 0 and lower limit also will give 0. Finally the answer is 0. So inner product are 0, therefore we can say, go back to the problem, here this set is orthogonal set, and to find the norm, next question is find the norm. How do you find the norm? So once inner product is 0, we have concluded that the set is orthogonal. Now we will find the norm of this elements. Norm means you should find n is equal to m. Take sin x, sin nx with the sin nx, isn't it? This is norm of sin nx whole square. So integral 0 to pi sin nx dx. You can write integral 0 to pi sin square nx dx. We have a formula for sin square in using double angle, 1 minus cosine 2 theta. Theta is nx, isn't it? Sin square theta is 1 minus cosine sin square theta is 1 minus cosine 2 theta over 2. You remember this formula? So here theta is nx, cosine minus 2 nx over 2, there is into dx. Now you can write this 1 over 2 outside and integrate term by term. Integration of 1 will be 1 dx will be x, integration of cosine will be sin 2 and 2 nx over 2n from 0 to pi. Now simplify and check. When x is 0, 0 sin 2 nx is 0, upper limit will give you, when x is pi, this is pi, pi minus 0 for upper limit, minus, when x is 0, everything will be 0 for lower limit. So this is 5 over 2, that is norm of sin nx whole square is 5 by 2. This gives norm of sin nx is equal to square root of 5 over 2. So now of the function it's been taken 5 over 2. Whatever the n is. N is 1, 2, 3. The answer is 5 over 2. That is it. For problem number 12, we have to verify. Now let us solve problem number 12. So note down, I'm going to the white sheet. Here the function is 1 cosine np n pi x over p sin n pi x. So this is actually theta. This is the theta. Okay, 1 cosine theta sin theta. It's a series of functions. You can write n is equal to 1, 2, 3 m. They are integers, remember. In the interval negative p to p, negative p and positive p. Here it's p. So when you expand this set, it will be 1 cosine pi x by p cosine 2 pi x by p cosine 3 pi x by p will go, and sine 1 pi x over p sine 2 pi x over p. It will go on this one. So it's an infinite set that has all cosine and the sine terms along with the 1. So we have to verify this is an orthogonal set, so that any pair you take from this set should satisfy the inner product is equal to 0. So that how to verify? You have to check 3 cases. Cosine with cosine, 2 different m, isn't it? Cosine with cosine. Next, cosine with the sine, and then 1 with the cosine, 1 with the sine. There are 3 cosine with the cosine, one case, sine with the sine, second case, isn't it? Cosine with sine, third case. The product of these 3 should be, these 2 should be 0, these 2 should be 0, these 2 should be 0. You can take any pair, and finally 1 with the cosine, 1 with the sine. All these inner product are 0. Then you can say you take any 2 elements from the set, the inner product will be 0. That is, any randomly chosen pair satisfy the property of inner product, which is 0. Okay, that's what we are going to see in this problem. Let us start with it. See, for sine n, sine with the sine, we have done it here for n. If it is true for n, it is true for n pi by p. It's another constant. Thus n is another constant. N pi by p is another constant. So I don't want to verify again for inner product of sine n pi x over p sine m pi x over p. We assume that it is true from the first problem. Okay, we are going to verify for cosine with the cosine and sine with the cosine, then 1 with both the functions. We will verify all these things. Finally, we will end to find norm of each function. Norm of cosine, norm of 1, norm of sine, 3 different norms. That's, we will go to different. So remember this function, we will write it again and we will check, right? Okay. The problem is, again I am writing problem number 12 from the textbook. This is set 1 cosine pi x by p cosine 2 pi x by p cosine 3 pi x by p is going, and sine pi x by p sine 2 pi x over p sine 3 pi x over p. So this is an infinite set. So we want to say that this set is orthogonal, so that every pair is orthogonal. And we have already proved that for sine n pi x n not equal to m, isn't it? P sine m pi x over p, the inner product is 0. Refer the previous problem, right? The similar type. So we are going to try here for n not equal to m. Cosine n pi x over p, cosine m pi x over p, two different cosine values, maybe cosine 1 pi x, cosine 3 pi x, 2, 4, anything, which is the limit given in the problem is negative p to positive p. We have to write cosine n pi x over p cosine m pi x over p dx. Remember, these two are even functions. The product of even function is again even function, so the integrand is an even function. What is the conclusion? I can write this limit negative p to p as 0 to p twice, only when the integrand is even function. Okay, and now I repeat this 0 to cosine n pi x over p cosine m pi x over p dx. Now we should recall another formula to write 2 cosine a cosine b, cosine a cosine b, isn't it? Let's go back to the formula collection and we will find formula for cosine a cosine b. The next page, this is actually equation number 1. We will write the rules. What is the formula for 2 cosine a cosine b? We know that cosine a plus b is equal to cosine a cosine b minus sine a sine b. Cosine a minus b is equal to cosine a cosine b plus sine a sine b. This is a and this is b, we have to add. Now a plus b will give you left hand side cosine a plus b plus cosine a minus b. The right hand side, these two will be cancelled. You will get 2 times cosine a cosine b. So we want, so the cosine a cosine b, take 2 to the left side. So what do you get? Cosine a cosine b is equal to 1 over 2 cosine a plus b minus cosine a minus b. We have already done a formula for cosine sine a sine b in the last problem, isn't it? So this one from b minus b plus a. This remember this formula, and this will be used in equation number 1. This is cosine a cosine b. The difference in here a is n pi over p, x is common factor. You can say n pi x, this is a, this is b. So what we got to write, equation number 1 gives, so equation number 1 gives what? This one on the left side. Inner product of cosine n pi x over p, comma cosine m pi x over p is equal to 1 over 2 integral 0 to p. Now use this one instead of cosine a b. Go here, cosine a plus b. Well, I am writing here cosine cosine n pi plus m pi over p times x cosine A plus B. Next minus, there is a 1 by 2, so this 1 by 2 is here, minus cosine A minus B, cosine n pi minus m pi over p x dx. This 1 by 2, this 1 by 2, it will be 1 by 4 outside, isn't it? Because there was another 1 by 2, oh no, it is 2 in the outside, it was not 1 by 2, it is 2. So this is 2 with 1 by 2, it will be 1. The next page you will write, which is equal to 1 from 0 to p. What we got to write is common term n plus common term pi p, everything can be done. So I write in this way, this one, cosine n plus m pi x over p. The variable is x, everything else is a constant, isn't it? Minus cosine n minus m pi over p times x. Dx. Now we have to start integration. When you integrate cosine, you remember this formula, cosine integration of cosine kx dx will give you sin kx over k. The coefficient of x will be in the denominator. That should be remembered. So we get, when you integrate, what you get is sin n plus m pi x over p divided by the coefficient n plus m pi over p minus sin n minus m pi over p x divided by n minus m pi over p from 0 to p. So you are going to substitute x as p. When you substitute here x as p, this p and p will be cancelled, sin n plus m times pi. Since n and m are integers, sin n pi, n times pi, will be always 0 when n is integer. So n is integer, m is integer, summation is also integer. The term will be 0, sin any integer times pi. This is pi. When x is p, p and p will be cancelled. So it will be 0 minus 0 for upper limit, 0 minus 0 for lower limit, the answer is 0. Therefore, this is done for sine versus sine. Cosine versus cosine. This is cosine versus cosine, isn't it? Already we assumed sine versus sine has been proved in problem number 9. Now, sine with the cosine. We will try sine with the cosine. Okay. In the same way, we have to try inner product of negative. So we have to, inner product of sin n pi x over p with cosine n pi x over p. We can take this m and assume n is not equal to m. This is 0 minus p to p sin n pi x over p multiplied by cosine n pi x over p dx. This is sine and cosine. The formula again you should recall from those collection of I will show you to write the formula for this one. Call it equation number 1. Case number not 1, maybe 2. So we have another set of formulas. We call it sin A plus B is sin A cosine B plus cosine A sin B. Similarly, sin A minus B is sin A cosine B minus cosine A sin B. When you take this one, this as equations 1 and 2, now 1 and 2, 1 plus 2 will give you on the left hand side sin A plus B plus sin A minus B, but on the right hand side these two part will be cancelled. We get 2 times sin A cosine B. So we want only sin A cosine B, take 2 to the left. That is happening here. This is sin A cosine B, which is equal to, so sin A cosine B is equal to 1 over 2 sin A plus B plus sin A minus B. This should be used, take it as equation number 3, should be used in 2. Now equation 2 becomes net product of sin n pi x over p cosine n pi x over p is equal to integral 0 to p sin A cosine B becomes sin A minus B or A plus B. It doesn't matter. First n minus m pi x over p plus sin n plus m pi x over p dx. Now integrate term by term. This is negative p to p, not equal to p. There is 1 by 2 as well, because the conversion formula gives 1 over 2 outside. When you integrate sin term, you will get cosine n minus m pi x over p divided by, this is theta, divided by n minus m pi over p plus again cosine n plus m pi x over p divided by the constant is n plus m pi over p. Now from negative p to positive p, 1 by 2 outside, p should be replacing x, isn't it? So when you write p here, this p and this p will be cancelled. You will get only cosine n minus m times. See, remember an important formula here I am writing. Cosine ax, a can be any constant. Then the cosine pi a, cosine k times pi x. X is not there, x is cosine k times pi. Cosine k times pi, that's what I am going to say. K is any integer. So k, when k is 0, cosine 0 is 1. K is 1, cosine pi is negative 1. K is 2, cosine 2 pi is positive 1. So it is either negative 1 or positive 1. Negative 1 to the power k. The coefficient of pi will be coming in the power of negative 1. That is the rule. So here pi, the coefficient of pi is n minus m. When you substitute x is p, the first term becomes minus 1 to the power n minus m. Plus second term becomes minus 1 to the power n plus m. That is for upper limit. minus, substitute minus p. Here x is minus p and p will be cancelled, there will be negative. Since cosine is given function, negative will be consumed by cosine. So you get again n again minus 1 to the power inside bracket n minus m plus minus 1 to the power n plus m. Now you simplify this term will be cancelled, this term will be cancelled, you get 0. So inner product of sine versus cosine is also 0. Sine is sine 0, cosine is also 0. We got to verify the product of the function 1 with the sine and the 1 with the cosine. Okay, let's do it here. Then we can say the function, the set is orthogonal, and then we can individually find the norms. Now inner product of 1 with the cosine n pi x over p, which is minus p to p cosine n pi x over p. 1 is 1, isn't it? Dx, and then integrate, what you get? Cosine will be sine n pi x over p divided by n pi over p, and from negative p to p becomes, when you substitute p here, n pi, sine n pi is 0, minus negative p also gives 0, so it is 0. Similarly, you can verify 1 with the sine n pi x over p. Again it will be 0. So you take any pair from the set, the inner product is 0. Therefore the set is orthogonal. Now we are going to verify it is orthonormal. It means the norm of everything should be 1. If not, it's just orthogonal set. That's all. Now we are going to find the norm of every possible element in the set. That is norm of, there are 3 different possible elements in the set. What are they? 1 cosine n pi x over p sine n m pi x over p, isn't it? This will be repeating for n and m when n and m are 1, 2, 3. So what is norm of 1? Norm of 1, integration from negative p to p, 1 into 1 dx. So x from negative p to p, p minus of minus p, which is 2p, which is 2p. That is norm of 1 square, which is inner product of 1, 1, it's 2p. Therefore what is norm of 1? Square root of 2p. Similarly, let us find norm of cosine n pi x over p whole square, which is inner product of cosine n pi x over p, cosine n pi x over p. When n and m are different, the inner product will be 0. But now they are same. Here n and n, isn't it? So we got to integrate. We have to integrate from negative p to p, cosine and cosine, which is cosine square n pi x over p dx, and we use double angle formula, negative p to p 1 plus cosine 2n pi x over p dx divided by 2. You remember the formula? Cosine square x is equal to 1 plus cosine 2x over 2. For sine square it will be negative, that's it. So if x is here, it will be 2x here on the right side. That's the difference. Now integrate this one. Integrate this one, what you get is First 1 by 2 can be taken out, say integration of 1 will be x, cosine will give you sine. Sine 2n pi x over p divided by 2n pi over p from negative p to p. It's not 0. Okay, substitute p for x, you will get p plus, here p will cancel with this p, therefore sine 2n pi will be 0. This is for upper limit, minus lower limit also again give negative p here, and this term will be 0. So this is 2p over 2 will be p. So the conclusion is inner product square cosine n pi x by p whole square is equal to p. Therefore, what is the norm of cosine n pi x over p, which is square root of p? In the similar way, you can try sine n pi x by p norm will be also root p. So that is it. Norm of 1, norm of cosine, norm of sine have been found. In the similar way, you can try integration, because sine square it will be integration minus p to p sine square n pi x by p, and sine square can be written as 1 minus cosine 2 n pi x over p whole divided by 2. Now integrate, substitute upper and lower limits, you will get p. Okay, you try this part, and I go to the last problem of this section. Verify by direct integration that the functions are orthogonal with respect to the indicated weight function. Now there are three functions, L0, L1, L2. Weight function is given. So we have to check integration of inner product of L1, L2 is 0 with respect to W. L0, L2, isn't it? And L1, L2, this has to be done with respect to W of x. Wx will join every club. This is what we are going to do, right? First one, verify inner product of L0 with L1 with respect to the weight function. So integrate with along with the Wx, W of x, L0 of x, L1 of x dx. The limit is 0 to infinity. W of x is e power minus x. L0 is 1. L1 is 1 minus x plus 1, so dx. Use UDV method. UDV method, I mean, u can take u is 1 minus x, u prime is minus 1, u double prime is 0, and here we can take v is equal to e raised to negative x, b1 integration of e power minus x is e power minus x divided by minus 1, v2 will be again e power minus x divided by plus 1, and v3 will be minus e power minus x, again it will continue. So we can write a direct formula, integral u v dx is u v1 minus u prime v2 plus u double prime v3. We don't have u double prime, so only first two terms. U is 1 minus x, but v1 is negative e power minus x. This is u v1 minus u prime is minus 1, and v2 is positive e power minus x. Substitute from 0 to infinity. Now I erase some part to find some place. I'll just erase this part. I want space to complete this problem. Okay, then we finish here. What is happening? Substitute upper limit here. X is infinity makes this infinity e power minus into 0. So 0 into infinity is indeterminate form. Indeterminate form can write the first time. Minus this one. Minus 1 will be plus e power minus infinity will be 0. Upper limit will give this one. Indeterminate form and 0. There is nothing. Minus lower limit. X is 0 makes this term 0, but 1 is there. Minus e power 0 will be 1. So minus 1 plus e power 0 will be 1. So this is plus and minus 1, 0. Everything is 0. So the inner product of L0 and L1 is 0. Next, L0 and L2. Finally, L1 and L2. These are the works to be done. Let's do it all here. Next, inner product of L0 with L2. L0 with L1 has been done. Now L0 with L2. With respect to the weight function, so we will write weight function W of x, L0 of x, L2 of x dx from 0 to infinity, which is 0 to infinity. W of x is e raised to minus x, L0 of x is 1, L2 of x is x square over 2 minus 2x plus 1 and dx. Again the same concept we will do. The formula is integral u v dx. Integration by parts, you can write u v1 minus u prime v2 plus u double prime v3. It's going on. Minus u triple prime v4 plus, isn't it? Until there are derivations for u. Since u is algebraic function, it will stop at some stage. So this formula is easy. A different version of the integration by parts. What is u? U is x square over 2 minus 2x plus 1. So what you want, u prime is 2x over 2. It is x minus 2. U double prime is 1. U triple prime will be 0. So to this time we need 3 terms. We want v1, v2, v3. We know v1 is v is e power minus 6. v1 is negative e power minus 6. v2 is positive e power minus 6. And v3 is e power minus 6 with a negative. v3 is negative e power minus 6. So we have elements that for use in the formula u v1. U is x square over 2 minus 2x plus 1 and v1 is e power minus negative e power minus 6. U v1 minus is here in the formula. U prime is x minus 2 and v2 will be e power minus 6. Third term, u double prime is 1, but v3 is negative. So this will be negative e power minus x. Now from 0 to infinity, 0 to infinity. So substitute upper and lower limit. What we get is upper limit See, infinity. Infinity will make this 1 into infinity, this 1 into 0. 0 into infinity is indeterminate form. Minus, again this will be indeterminate form. This will be e power minus e power 0 is 1. E power minus infinity is 0. So upper limit gives nothing. Minus lower limit. X is 0. This term will give 1. This term will give minus 1. So minus 1. This term will give plus 2. Plus 2. And this term will give minus 1. So plus 2 minus 1 will be 0, and the answer is 0. We have verified L0, L2, and finally we have to verify L1 with L2. That will conclude this problem. L1 with L2, right? The same way we will proceed. Integration inner product of L1 with L2, which is with respect to the weight function 0 to infinity. Weight function is e power minus x. L1 is 1 minus x. L2 is half x square minus 2x plus 1 into dx. Now we multiply these two algebraic functions together, and we will write it 0 to positive infinity e power minus x. When you multiply these two and simplify, you get minus x cube over 2 plus 5 over 2x square minus 3x plus 1. Verify yourself. And dx. Now again the same concept. This is your u. U is algebraic function. This is u, this is v. Isn't it? U is minus x cube over 2 plus 5x square over 2 minus 3x plus 1. So u prime will be minus 3x square over 2 plus 10x over 2 minus 3. This 10x will be cancelled by 5. So u double dash will be minus 6x over 2 can be cancelled, it will be 3 plus 5, and u triple prime will be minus 3. So fourth derivation will be 0. 3 derivations are enough. Therefore, what is v? V is e power minus x. V1 is e power negative e power minus x. V2 will be positive. V3 will be negative. V4 will be again positive. So we will see what is the formula. Integral u v dx, another different version of the partial in integration by parts. So this is u v1 minus u prime v2 plus u double prime v3. We have u triple prime minus u triple prime v4. The fourth derivation of u is 0, so only 4 times. Substitute all the terms here and take the limit 0 to infinity. U minus x cube over 2 plus 5x square over 2 minus 3x plus 1 times v1. v1 is negative e power minus x minus u prime. U prime is minus 3x square over 2 plus 5x minus 3 into e power minus x. Next, plus u double dash and v3 is negative, so this is negative minus 3x plus 5 into e power minus x. Finally negative. Third derivation is negative 3, so it will be positive 3 e power minus x positive, all from 0 to infinity. Can you check how the answer is going to be 0? When you substitute upper limit infinity, this will be infinity and this will be 0 indeterminate form. This will be infinity and this will be 0 indeterminate form. This will be infinity and this will be 0 indeterminate form. Finally, infinity will give you plus 3. upper limit e power minus infinity will give you 0. So plus 3 times the upper limit gives nothing, minus lower limit x is 0. This 3 times will be 0, but there is 1. 1 into e minus e power 0 is 1, minus 1. Second term will get minus 3, this minus plus 3 e power 0 is 1, so plus 3. This term will give you 0 plus 5, negative 5. Negative 5. Negative 5. And this final term will give you plus 3. Therefore, plus 3 minus 1, answer is 0. So, any two pair, the inner product of any two pair leads to 0. Therefore, the set of L0, L1 and L2 is an orthogonal set. That has been proved. That's the end of this problem. And the answers are here, you can find. Fourier series, the next chapter will be discussed in the next video. Thank you very much, gentlemen.